Hi guys, today we're going to quickly recap Unit 5. I'm going to try to keep it under 10 minutes for you today. So what are we doing today? Today we're talking about a sampling distribution for a statistic. And that statistic is either going to be a proportion or a mean. And how do I know? Well, with the mean, they usually say average or mean in it. So that makes it pretty clear. With the proportion, it's always a categorical variable. With a mean, it's always a quantitative variable. Really, when you're drawing conclusions about a sampling distribution when it comes to the free response questions, you are going through the state, plan, do, and conclude. But here's the deal. There's no null hypothesis or alternative hypothesis. You are only asked about the probability. So you still are finding a z-score, you're finding a p-value, but you're only drawing conclusions about that statistic. You are not drawing conclusions necessarily about that parameter. And that's what you do. You're drawing conclusions about the parameter, that null hypothesis, and that alternative hypothesis is about the parameter in significance testing, okay? When you have a null and an alternative. So I'll say it again. You're drawing conclusions about the statistic, the probability of that happening, but not about the parameter. You're not rejecting or failing to reject a null hypothesis. So let's get started. With a proportion, okay, with the state, plan, do, conclude. With this state, you're going to take the probability that the statistic, okay, so what is that statistic going to be? That statistic is either going to be a p hat, or if you have two samples, it's going to be p hat of 1 minus p hat of 2. And then you take whatever that p hat is. So, for example, if I interview 100 people and 80 of them love cheese pizza, you would put 0.80 there. If I look at Cooper, how many people love cheese pizza there? And at Armstrong, how many people love cheese pizza there? I would subtract the proportions and I would put those there. And then the statistic here would be that p hat of 1 minus that p hat of 2. So again, you're just deciding, is it one sample or is it two sample? What statistics am I dealing with here? Okay. For the plan, we go through the RIN process again, random samples. The independence, the I is that 10n has to be less than capital N. And then for a categorical variable, when we're dealing with proportions, that's that NP has to be greater than or equal to 10. And N times 1 minus P has to be greater than or equal to 10. And again, what is P? P is your parameter. What is describing the population, okay? So when we're dealing with this model, right, we draw our curve and the parameter always goes in the middle. So if it's a 1 sample, it would be a P equals, and if it's a 2 sample, it would be P of 1 minus P of 2. Okay. Now with your standard deviation then, that's where you're going to want to go to your formula sheet. Okay. That's where you're going to want to go to your formula sheet. So for example, I'll just do it just to save us some time. That first one is P times 1 minus P over N. What I'd like you to do is I want you to go to the formula sheet and make sure you're familiar then with the 2 sample. We do not pool with that 2 sample there, okay? All right, the statistic, what is the statistic we're dealing with? The statistic we're dealing with, okay, is if it's 1 sample, it's P hat. And what is P hat? P hat is the part over the total, okay? And if you have 2 samples, then it would be P hat of 1 minus P hat of 2, okay? So again, we have our parameter, what's describing the population. We have the statistic, what we observed, and then we have the standard deviation. This one's for a 1 sample. Just a friendly reminder, if it's a 2 sample, okay, and you're not pooling, you would have that 1 there, and then 1, and then you would add with the 2, okay? Again, I don't want to waste the time right now, so go and check your formula sheet, make sure you understand that piece. Okay, and then once you have this all set up, you go ahead and you find your z-score, ZOMS. Z is equal to what we observe, minus the mean, divided by the standard deviation. The statistic is what we observe, minus the mean, that's our parameter, divided by our standard deviation. You go to your table, you find your p-value. I've talked about how to find that p-value in other videos, so check that out if you've forgotten how to use that table. Okay, I'm going fast. At this time, pause it, rewind and watch, or write down anything that you need to address a little bit better. Let's go to the means. Okay, so now we're dealing with a statistic, and the statistic in this time is an average. So for example, I could maybe say, what's the average height of 9th graders at Armstrong High School? Okay, that would be then an X bar. And that number here is what I found for that X bar, okay? So the average height is, 55 inches or whatever, okay? You would put that number there, and then you put that less than or greater than, depending on what the question is asking. It will not be a not equal on this one, okay? Well, I lied. It could. Forgive me. It could be a not equal to. It just depends on the question. Usually what I've seen is a greater than or a less than on this one, but it could be a not equal to. Okay. Then we need to go to our conditions, our RIN. We have a random sample. Independence is still that same one that it is for proportions. 10n is less than capital N. But this time, our normal condition is n is greater than or equal to 30. And that's because of the central limit theorem. Okay, and I'm going to talk more about the central limit theorem on the next slide. So now we're ready to set up our sampling distribution for a statistic, that model, okay? This time we have a parameter. Our parameter is either going to be a mu, so what is describing the population right now, or a mu of 1 minus a mu of 2. That's if you have two samples, you're given two parameters, and you're talking about differences. Then our statistic, that's what we observe. Okay, I had to pause it for a second, so forgive me if I was off. Your statistic is your X bar, if that's what you're observing with one sample, or if it's two samples, it's X bar of 1 minus X bar of 2. Okay, so next you're going to go ahead and you're going to find your standard deviation. And your standard deviation is the standard deviation, okay, over the square root of n, okay? Now, why don't I just go ahead and I'll pull up your formula sheet, because I'm worried you're not going to do it and I want you to know where it is. So give me a second here. You really want to become one with that formula sheet, you guys. Oops, I went right to it. Sorry, my son's outside, so I'm watching him too. I make this video. Okay, so here's your standard deviation for one sample, and then here's your standard deviation for two sample, and you will not be using this one right here. Okay, so let's go back. So we have our standard deviations, we have our statistics. Statistic, what we observed, it's describing the sample. Right here we have our parameter, that's describing the population. And then we have our standard deviation based on if it's a 1 sample or a 2. So from there, we go to the z-score, okay? We go to the table, we find our p-value. If you need help with that, check back at other videos. All right, I'm at the 9-minute mark. I don't think I'm gonna make the 10 minutes. Let's quickly talk about central limit theorem. While I go over that, I don't foresee this happening on a free response for this year, for 2020. But what is a sampling distribution? A sampling distribution is where we take samples from a population of the same size, and we have all possible samples. We plot it out, and we get this curve, okay? When we're dealing with this, we're dealing with a model, a model of a sampling distribution for a statistic, but that has typically been a multiple choice question where we deal with, is this a true sampling distribution of a statistic, okay? And so I just wanted to put that out there, that what is a sampling distribution of a statistic? We have this population, okay? And we did a little activity in class where we went around and you asked 3 people, how much sleep did you get? And you got the average. And then we talked about, is this a true sampling distribution? And it wasn't, because we needed a sample of all 3, Okay, a sample size of, I'm screwing this up, forgive me. We need a combination of all combinations of size 3 from that class to be a true sampling distribution. Forgive me, there's a lot going on outside here. So let's finish up, you guys, with the central limit theorem. This was an activity. I'm not certain that we did it this year in class, but I've done it in class before, okay? So I'm going to just read through it real quick. In this activity, you'll be taking an SRS of various sizes from a population whose distribution is very skewed. So I just said, hey, this is the ages of whatever, people in the room, doesn't matter, okay? So we have this big population. Imagine it's very big. Well, we're going to start taking a sample size, and this was a simulation we did, and I showed you how to do it, and we came up and we plotted what was happening. So the first thing is we went up and we plotted a sample size of 5, okay? So it comes from a skewed population. Now, these X bars, these are all averages of size 5. So there's 5 numbers taken, an average was found and plotted. And you can see that, hey, it still is skewed right, okay? It's still skewed right. Then we increased our sample size to 10. And although so now each one of these X's represent an average from a sample of 10, okay? It's still skewed, but it is not as bad, okay? And we continue to increase our sample size, and you can see as we get to 25, what happened there as well, okay? We're more symmetric now, and that's where the central limit theorem comes from. As we increase our sample size, and we need N to be at least 30, our sampling distribution of that statistic will be normally distributed, okay? And so that's what that sampling distribution of a statistic is. The last thing I want to just quickly talk about, and I'm just going to quickly draw this, is what is a biased statistic versus an unbiased statistic. So a biased statistic would be, hey, I want to estimate the true proportion of people who are going to the U of M, okay? And I ask a bunch of people and I plot. So I take a bunch of different samples from, let's say, the Northwest metro area, okay? And I'm plotting from the Northwest metro area what percentage are going to the U of M. So based on this curve, okay, I would estimate the center to be around here. Let's just play pretend and say that that's 60%. 60% of kids from the Northwest metro area are going to the U of M, okay? Now, what we find out later is we find out from the U of M that actually it was 80%. This statistic that we used here, right here, the 60% to estimate the true percentage of people who are going to the U of M, this was a biased statistic, okay, because it totally missed the boat. However, that sampling distribution has a nice job of not having much variation, right? Okay, so let's talk about it one more time. Let's say this time we want to find out the average number of people who live in a home in the Northwest metro area, okay? So we start plotting and we find, you know, right here. Okay, and now we see, okay, it's a little skewed, not really a bit. I'm just doing this pretty fast. Right here's the average, okay? And let's just say on average there's, you know, 5 people in a home, okay, that live in a home. And then the United States Census came back and they actually told us, hey, it was 5.1. That statistic has done a pretty good job of actually estimating the true average of how many people are living in that home, okay? It's approximately equal to the true parameter. So when the statistic, the center of that model is approximately equal to the true parameter, it is an unbiased statistic. Now, the issue with this, though, is this is pretty spread out. There's a lot of variation here, and we don't like a lot of variation in statistics. So just remember to increase your sample size, your variation will go down. I'm done. Was not my best video today. My son is kind of in and out, and my mom just pulled up in the driveway to social distance. So I am gonna go on a social distance walk right now. And if you have any questions, let me know. I'll gladly redo something, go slower, whatever you need from me to be successful. You guys have a great day.